As I said in the previous video, it's often quite surprising to students that adding resistors can decrease the resistance. But it's because we open up new roads for current to travel on, or traffic to travel on. So I've got the one resistor circuit here again. Notice what the current of 0.087 and the voltage of about 10. Let's zoom in and look at the resistor itself. What I'm going to do is I'm going to put resistors so that their feet are in exactly the same rows of holes on both sides of the breadboard. And that's going to open up new paths for current to go from the red positive side to the black negative side. And we'll see what happens to both current and voltage across these resistors. All right, so here's my one resistor circuit. So I've got a voltage of about 9 and a current of 0.087. So I'm going to throw in another resistor. Again, this is in parallel, so I'll put its foot in the same row of holes as the first. Over there and over here. And if we look, something interesting's happened. The voltage has stayed exactly the same. It's still about 9. But the current has roughly doubled. It's now 0.165. And now we'll do the same thing. We'll put a third one in. So this row of holes. That row of holes. And now we're up at still at about 9 volts. But our current's gone up to 0.24. So there's our 3 resistor and parallel circuit. You can see all their feet are wired together on this side, and they are on the other side too. And again, just think of each resistor as a highway. And as you open up new resistors, there's more paths for current to flow. If we look at our data, it bears that out. The voltage stayed the same in each case, but the more resistors I added, the more current flew through the power supply.